about deep fakes. So, for those of you that don't know, just really quickly, a very quick intro. I am Alyssa Miller. I'm a hacker and a researcher. I'm also an application security advocate for Sneak. Many of you might be familiar with us by this point. Additionally, I am an author and a blogger. I'm currently working on a book to serve as a guide to help people get their careers started in information security. I do also blog both within the Sneak blog as well as on my personal website as well. And I will share that information with you at the end of this. Then finally, I am the co-host of a podcast on ITSP Magazine called The Uncommon Journey. If you've been on the conference for a while tonight, this morning, whatever, you actually saw my two co-hosts, Chloe Mastagi and Philip Wiley, who also presented in this track as well. But I'm going to take you on a journey now, and it's a journey of sight and sound. Now, when I was a kid, my parents took me to what we call here in the States a fun house. Now, I don't know why they call this thing a fun house. It's basically like a gigantic maze that you walk through, and it's filled with all sorts of optical illusions and other things to disorient you as you try to find your way out of this fun house. And I just remember being a very young child and going through this fun house, and every time I thought I found the exit here, or I thought I found it there, I'd run up and I would realize that my senses were playing tricks on me. I couldn't trust anything that I was perceiving. And when we start to talk about this concept of deepfakes, it really represents a new paradigm of attack where instead of attacking systems or attacking people, now we're attacking people's senses, the things that we use every day to determine what's real and what's fake all around us. So when I say deep fakes, what do I mean by that? Well, I am talking about any form of artificial media created by deep learning neural networks. So it might be images, it might be audio, or the most common one that people think of when they hear deep fakes is video. Now, where did deep fakes begin? Well, as is often the case, a lot of times when we have promising technology, the first industry that really picks up on it is the porn industry. And indeed, that's what happened with deep fakes. As researchers early on started coming out with deep fake technology in 2017, it didn't take long before we started seeing websites making deep fake videos where they took a normal pornographic video, they took their actress out of it and put the face of a celebrity like Natalie Portman or Gal Gadot or Natalie Dormer, Emma Watson, and others. And in fact, still today, there's websites that will do this, and some of them even take requests, and you can pay an amount of money, and they'll make a deepfake porn video of whatever celebrity it is you want to see. Now, it didn't take long from that humble beginning to jump into politics, and certainly I think many people have seen a lot of the videos that are out there of different characters being deepfaked within videos. If you don't recognize any of these, you might recognize one from 2018 where they deepfaked Barack Obama saying some less than kind things about the current president of the United States and so forth. But the attack vectors extend beyond deepfakes. So I mentioned audio and deepfake audio before. Social engineering is a real concern when we think about deepfakes. So there's an example that comes to us out of the UK of an energy company where the CEO was tricked into transferring 200 million euros to attackers because they used deepfake audio to convince him that the president of that energy company's parent company was calling him and instructing him to make this wire transfer. So as this technology goes beyond just video and into audio, it represents a real threat in terms of social engineering. And so as we start to think about, how this applies to the business environment, the potential to use this for extortion is another real threat. Now, I show this example up here. Obviously, I think we probably all recognize that face, the head of Amazon. Indeed, everything I understand of this, that all the videos and stuff were real. Nothing was deep faked. But how much of a leap is it that someone looking to extort a high-ranking CEO might use deepfake, the threat of a deepfake video being released, to try to extort money or other actions from that particular CEO? Even if they know it's fake, just getting that out into the media could be damaging. And if their spouse sees it, it could be impactful to their marriage as well. And the fact that it comes out later that it's false might be too late. But the threats extend beyond just extortion when we start talking business. And there's this idea that I call outsider trading. So we're all probably familiar with insider trading, where somebody uses insider knowledge of an organization to make stock market trades based on their anticipation of stocks going up or down. So consider this now. We'll take Elon Musk and Tesla, and let's say Tesla's getting ready to launch their newest model. We'll say the Model Q. And the night before they're ready to have their big launch, a deepfake video of Elon Musk talking to investors, telling them how the line is experiencing problems and they're going to be late in shipping and they're going to have all sorts of issues. That makes its way onto the internet the night before. Well, what happens to that stock that was soaring because of this pending announcement? Well, that stock is going to drop. And now that attacker can buy that shorted stock. And after news comes out that this video was phony, it was just a deep fake, the stocks rise, attacker sells off that stock. You now have this concept of outsider trading. But if I can do that to a large organization, can't I also do that to whole industries, entire markets? What about maybe even the economies of small countries? The fact is we have so much in our world that's dependent on our trust in information that when that information is threatened, it goes right to the core of how these systems work. So what is real? How do we define it? We use our senses every day to perceive the world around us and to make those judgments of what is real and what is fake. So let's talk about how these videos, for instance, are created. And they're ultimately created using what we call a generative adversarial network, or a GAN. Now, if I break that down, it's generative in that it's creating something. It's adversarial in that there's two networks within this GAN. The first is called the generator. The generator's job, as the name would imply, is to create the phony images or the phony video. The discriminator then is the adversary to that network, and the discriminator is there to determine how realistic those images actually look. Both sides of this equation are trained with training images. And so the discriminator understands what it's trying to match up to. The generator understands effectively what it's trying to create. We pass it a target media. So that's the media that we're going to replace a person in. And we're trying to create this subject. So the generator creates these images. The discriminator looks at them and says either, yeah, that looks real, or no, that looks pretty fake. And it then passes information back to the generator so that the generator can improve what it's doing. Now, how does this actually work? So we're going to look at some deep fake media that I did of myself. And so what we see is, as we're training this within this network of the generator, there's this idea of encoding. And what encoding really is, what the encoder does is it takes an image, and you can see from the way this image is shaped that these images get standardized to a square image of a specific size. And that's so that as we're building these models in our deep learning networks, they're working with consistent data that's all normalized. So the encoder then takes that image and tries to describe it in a mathematical sense. So everything is numeric. It's taking all the aspects of that face, typically 68 different landmark points in facial recognition, other information about expressions and so forth, angles, the alignment of the face, All of that gets encoded into a numeric model. Then we have this decoder, and that decoder is trained to use that model to regenerate that same image. And then the discriminator takes a look at it and says, okay, how much does this really look like the original image? It calculates this thing called loss, which is just a measure of how realistic, how good is the result. And then it updates that model, and it updates what we call the weights. And the weights are what impact those numeric values and provide that feedback. So when we're actually training a GAN, what we're doing is we're actually training it on two sets. We're training it on our target face, which is the face that we're going to replace, and the subject face. But we're training one encoder to be able to encode both of those into that numeric model. But then we're training our decoders to be able to take that common numeric model and create either image A or image B. And so as we are in that training and it's getting better and better, we see over time that those images improve. Now what we do when we feel we have a strong enough model, when that loss value is low enough that and the results look good enough, we do a conversion. And the conversion is what actually will create the final media. And all we're doing there is we're taking that image of the target, we're passing it to the encoder, but then we're using the decoder for the subject. And so now it's able to take all that information about expressions and alignment and everything else of my face, as you see here on the left, and turn that into Alyssa Milano's face that you see on the right. So this presents some issues, and we're able to detect visual cues in some cases and other things that tell us that videos are fake. Initially, we just were able to look at the fit of a face. Because we were using standardized sizes and everybody's face is different size and shape, there was warping and other artifacts that could be detected very early on. But deepfake technology has gotten better. So researchers next decided to look at blinking because they noticed that with deepfake videos, the amount of blinking that the final subject was doing didn't match up and wasn't realistic. Because if you think about it, most people don't have a lot of pictures of themselves out there on the internet that could be used for training that show their eyes closed. Well, indeed, the University at Albany released this study, and within months, deepfake technology was now replicating blinking. So they did some things. They started looking at velocities and other things about the nature of blinking. But at the end of the day, the ability to use blinking as an indicator is no longer a viable or accurate option for detecting deepfakes. So some other issues we have, I mentioned the standardized size, again, of these images that we use. And so here you have an example of Steve Buscemi's face being placed on Sharon Stone. And it's in this scene in the movie that it starts with this image, which looks pretty realistic. Her face is far enough away that using that standardized size of that image, this looks pretty realistic. Now, the issue is later in the scene, the camera zooms in. And because now that deepfake has to stretch and resize that image, we lose fidelity. And you can see the difference in terms of just the resolution of the face region versus the rest of her head. You also see some of the deformations that show up in the cheekbones and other things as a result of having to manipulate that standardized square image to fit a new size and a new shape and a new angle that doesn't necessarily match up exactly. So this has been useful, and it does make it harder when we have video that changes in that focal length. But if we've got a standard focal length, like say a press conference being given by a president, it's still not an effective way to detect a deepfake. So some promising stuff that's being done is actually looking at modeling behavior. So instead of trying to really just detect things, the artifacts and other things within the video, researchers are looking at, can we detect behaviors of an individual, how their face changes, how their facial expressions, other things that they do when they're delivering content of a certain type. So if they're very emotional, if they're very angry, or they're very, very mundane or subdued, how does their face change, and does that match up to what we see in that video? Now, this is very promising in that Dartmouth recently released their results on this, and they're seeing 95% accuracy. They expect to have 99% accuracy in detecting deepfakes by the time the 2020 US presidential elections roll around. Now, the problem with this, of course, is you have to do a lot of analysis of this subject. So it works great if we're talking about high-profile celebrities and so forth. But when it comes to the common individual, this type of behavioral information just might not even be available for analysis. So researchers are also looking at how can we just prevent deepfakes from being created in the first place. And what they're using in this research is what we call adversarial perturbations. Basically what it is it's unperceptible noise that's introduced into these images. So you can see this top row is the original image, and you can see from the rectangle that the facial recognition libraries easily identify that face. But when I drop down, I see what the image looks like after that noise has been injected in that second row. And I see that all of a sudden the facial recognition is identifying tons of different faces that don't exist, and it really is not identifying the real face. And then that final row shows you what that noise actually looks like that's being inserted to that image. So the human eye doesn't perceive this at all, but when it comes to the facial recognition libraries that deepfakes rely on today, we see how it prevents them from being able to read those images, and therefore they're unable to create or to do that training, create that model, and to create images from it. So these are lots of technological solutions, and they're great. But the problem is this is misinformation ultimately that we're dealing with. And misinformation is not a technological problem. It's a human problem. And so we need to address the human element in all of this. So the problem with misinformation, first of all, is that it's very sticky. It is hard to dislodge misinformation once it's in somebody's brain. And that's because, first of all, disinformation, it plays off of people's existing thoughts and beliefs and their predisposed knowledge and so forth. Basically, it gives them something they want to believe is real. And what happens then is that information gets inserted into a logic chain in our brains that just follows, because it's already information that fits with everything else we believe, everything else we're prejudiced to see, and everything else that we want to believe. So as a result, trying to remove that information that now is a part of this logic chain in our brain is extremely difficult. So how do we go about this? Well, to debunk misinformation, the first thing we have to do is we have to put the warnings out there that misinformation exists. So hearing about deepfakes in media and understanding that this is something that is being created with increasing reality is great. And indeed, when videos come up that are fake, getting the news out there as quickly as possible that, hey, this is a deepfake video, this is not the real thing, is crucial. It's also crucial that we repeat that information over and over again, that this is a deepfake, and we have to reinforce it again and again and again. So the media is getting better at doing this. We see social media is taking care of this as well. But the one piece that we still have to get better at is, in order to dislodge that information, we need to replace it with an alternative narrative. But that alternative, truthful narrative has to fit that logic chain. So we have to understand from the original mythical information, how does this fit in with the belief systems and the prejudices of the target audience that's actually believing this information? And then and only then can we craft a narrative around the truth that will fit into that logic chain and replace that information. Now, this is all really scary stuff. The good news is there are positive intentions here, and we're seeing positive uses of this technology. First and foremost, for all the Star Wars fans out there, you might remember these two faces making some appearances in some of the more recent videos. So, for instance, we have the young Princess Leia, or we have Grand Moff Tarkin, both being introduced into these videos. That was deepfake technology with GANs that was used to create them. We're also seeing GANs used in medical imaging. GANs are insanely more accurate than a doctor looking at an MRI in both identifying a tumor and predicting the future growth of that particular tumor based on what's seen in the MRI. We're also seeing research done around augmented reality. So here we see a form of augmented reality telehealth where this doctor isn't even a human being at all. That's just a deepfake generated image of common pleasing facial features and so forth that are meant to open up a particular person to be able to more easily talk with that doctor and so forth. So you think about automated telehealth, that's what they're looking at here. And then finally, returning to politics. This is one that's kind of impressive, but there's some argument as to how good or bad this really is. This is a political candidate from India, and his constituency involves people that speak 7 or 8 different dialects of the languages in India. So he wanted to be able to connect with all of his constituents. And so what he did was he recorded a video and then had that video deep faked, both audio and video, to now show him communicating the same message in all of those different dialects. And indeed it worked. He was very popular. He won the election by almost a landslide, and it was a really effective way. The last one I'll mention that I don't have an image here for you is that we also see this now in terms of course, security. We've all heard about deep learning and AI being used to make better security tools. Well, imagine GANs being able to analyze source code and identify whether source code is secure or not even thinking about specific types of vulnerabilities, but just being able to develop an overall model of what secure code looks like versus what insecure code looks like. Indeed, we've also seen research being done already by McAfee to use GANs and digital imaging to analyze malware, both fileless and self-morphing malware. And it's able to identify patterns, and it can pick out malware that otherwise would go undetected. So before I leave you here, I want to hand you this quote. This is from Yuri Bezmenov. He's a former KGB agent. This is from 1984. So this goes back to when the then Soviet Union was engaged in some pretty heavy efforts for mass brainwashing, both domestically within their own country and in other countries in the Western world. And this goes to the heart of what misinformation is all about and what the goals of misinformation are. Finally, if you want some more information, you can follow me on social media, #ProjectDeepfake. You'll see lots of different information out there from me on Twitter or LinkedIn with those hashtags. There's URLs here that you can follow that will take you right to those hashtags. There's also a URL. I told you I've done some generation of videos. You'll see the good and the bad, how easy it is to generate, and yet also some of the challenges in terms of how good or bad that can be. Here's some references, just some of the research papers that I referenced in this talk today. I encourage you to go check them out. I'll also mention one that's not here, which is MIT's Intro to Deep Learning is a course that is available to be viewed online. I believe the website is introtodeeplearning.com. But if you do a search for that, some great material there if you want to learn more about not just GANs and how they apply to deepfakes, but other deep learning concepts as well. And then finally, I invite you to continue the conversation with me. You see here my Twitter handle, my LinkedIn address, also my website that I promised you I would share with you. Feel free to reach out. Follow me, send me a DM. My DMs are always open. Hit me up through LinkedIn if you prefer that route. Always happy to discuss any security topics, certainly discuss deep fakes. There's some, new breaking technologies. I was just looking at Twitter a little while ago, and somebody's come out with it's arguable if it's really deepfake, but a library that's capable of doing some form of deepfaking in real time within video conferencing software like Zoom. So happy to talk to you more about that as I even do some more analysis into some of those things. So with that, I want to say thank you. Thank you from me, first of all, for attending this talk. Thank you from Sneak, from all the talks, from all of the sponsors of all the talks for joining us for this conference. This has been a really important effort for us. We wanted to build something community-driven that brought together developers and security and operational people all into one space and for the good of the community. We've raised over $70,000. I think last number I saw, we were approaching 80,000, and that was a few hours ago. We've raised a lot of money to help the World Health Organization combat COVID-19. We're helping people because that's what we do as a community. And so it's so important to us to have you here. The attendance has been wonderful. We cannot thank you enough. I want to also say a great big thank you to the entire crew of all the talks. We have had stellar performance. The streams have been available very consistently throughout. I think we had one little blip at one point on one stream. We certainly had some challenges with technological issues with speakers who we were able to overcome quickly and ensure their talks still happened. That's really impressive for something that we put together in 5 weeks. So to all the crew out there, Sam and Patrick, who spent countless hours putting this all together, everybody who had a part in making this a success, a big thank you. And again, thank you to everybody who's joined us here this evening or this morning, all throughout this 24-hour conference. We're coming up now on 23 hours, 999. So from me, from everybody here, thank you so much again for being a part of our conference.